Hello and welcome to another stop on the Grand Canyon North Rim's field trip. We're going to be taking a look at some faults, some interesting rock outcrops thanks to faulting, taking a look at the Paleozoic sequence of rocks, and some hoodoos along Crystal Canyon, both of those nice views from Crystal Canyon, and another great look at the Paleozoic sequence of rocks, and then some interesting layers that have been folded a bit out at Point Sublime. So where are we going? We're starting here at the just north of the Grand Canyon Visitor Center, campground, etc. Traveling on an old dirt Jeep road out to a stop here in this open area. Continuing on the road to the top of Crystal Canyon, roughly there, and down towards the end of the road to Point Sublime, which is there. Let's take a look at this in more detail. So let's zoom in on an area approximately there. So here was where we were last time. This is Transept Canyon. And the North Kaibab Trail travels down Roaring Springs Canyon here. So we're going to take an old dirt road it starts roughly there. We're going to travel to the northwest, look at an interesting and unusual outcrop of rocks approximately there, continue off to the west and stop at the top of Crystal Canyon about there, and then continue to the end of this road, which is called the Point Sublime Road, out to the end of Point Sublime, which is there. We'll be seeing views across the canyon looking to the south and off to the west. Let's take a look at the geologic map in the cross section. So again, here we are here's Bright Angel Point, here is Transept Canyon, and this is where we took our hike down the North Kaibab Trail. So we're going to drive this way and stop approximately here. Look at a small outcrop of the Coconino Sandstone, which is also this yellow color. We won't see this big patch, we'll see a small outcrop. Continue off towards the west to the top of Crystal Canyon, take a look at it towards the south, and then continue along the road to the end to Point Sublime. So what this map mostly shows, what we're going to be seeing up here is a bit of Coconino Sandstone. We're going to be taking a look down the axis of Crystal Canyon, which shows most of the Paleozoic sequence of rocks. And then we're kind of going to be looking at many types of rocks, especially the Paleozoic sequence as we look to the south and off to the west from Point Sublime. So we'll be having over here a good look at the Coconino Sandstone and most of the Paleozoic sequence. I think we'll only be able to see from about the Bright Angel and up to the top. Okay, here we are in this open area, not very forested. That'll be important here in a second. And here's the road that we're traveling on. In most places, any passenger car could travel on it, but in some cases, it's a little bit rough. And here we have an outcrop of rock. Now, in the Grand Canyon area, if you find some rocks at the surface, it's very likely that it's going to be the uppermost layer, the Kaibab limestone. But in this case, it's not. This is a layer or an outcrop of the Coconino Sandstone. The Coconino Sandstone, remember, is the third layer down in the suite of Paleozoic rocks. So what is it doing here at the surface? Well, two things. We're standing in an area called the basin, and the basin has a fault running through it called the Basin Fault. So it's not necessarily here, but it's approximately somewhere along the axis of the basin is the Basin Fault. And the rocks on this side have moved up the fault relative to the rocks on the other side. And so this whole side you can think of in the past has been moving up, and what used to be the overlying Toroweep layer and the Kaibab limestone above the Coconino have been eroded away, and here we have the Coconino Sandstone at the surface. It's unusual to have the Coconino at the surface, and so there had to have been some, relatively significant movement, vertical motion of these rocks in the past to bring it up and then just for erosion to strip away the Toroweep and Kaibab. One last thing I want you to note is the absence of trees here. Okay? This area is fairly heavily forested by conifers, and they really like growing in the Kaibab limestone, but they don't particularly like the Coconino Sandstone or the Toroweep for that matter. And so you can use vegetation sometimes as a clue to the geology and vice versa. And we'll see this again later in an area where the Kaibab limestone has been removed. There aren't any trees. Where there is Kaibab limestone, there's all kinds of trees. Let's continue on to Crystal Canyon. So here we are looking more or less to the south along the axis of the canyon. Okay, and it's composed of the Paleozoic sequence of rocks. The lowermost one we can see in this photo down here on both sides is the Redwall limestone. Above that we have the Supai group. We have the Hermit Shale, Coconino Sandstone, Toro Weep, and then there's a bit of Kaibab left on the top of that ridge. The thing I want to note is the linearity of how straight Crystal Canyon is. It appears to have a bit of curve. That's an artifact of the projection of how I'm displaying the picture. It really quite is a straight line from the top of the canyon down to the bottom. And you can see that over here too. It's a straight line from the top of the canyon down to the bottom. Why is that? Canyons carved by streams or canyons carved by rivers tend to be curvy. Rivers had a natural tendency to be curvy. So why are so many of the canyons in the Grand Canyon, such as Bright Angel Canyon here, straight, or Dragon Canyon here, essentially straight lines, or Crystal Canyon, straight lines? And the reason is that the canyons, yes, are carved by water, carved by moving water in streams, but the canyons form where they do because the rocks have been weakened in those spots by faults. Okay, let me get rid of some of the red lines down here. Every one of these faint black lines on the geologic map, like this one, like all of these, There's one that's hard to see, but it goes down the length of Bright Angel Canyon. And there's one here that goes straight down the length of Crystal Canyon. We're standing in an old fault zone. There are many, many faults throughout the Grand Canyon area, some of them Proterozoic in age, started as much as 1 billion years ago, some of them much younger, some of them like the Butte Fault, which started out as Proterozoic and reactivated later. And the Crystal Canyon is, like many canyons, formed along fault zones. The reason why the stream going down Crystal Canyon is where it is because the rocks there are weaker, they've been broken up, and more easily eroded. Because we're standing in a fault zone, and because the rocks have been broken by repeated earthquakes when these faults were active, water has an easier time penetrating into the rocks and breaking them apart. So let's zoom in and take a look at these guys here. So this is what they look like a bit closer, and there are a lot of vertical cracks. These are called joints. Here's another one here, here's one, here's a big one. Okay. These rocks broken up by earthquakes in this fault zone, water penetrates more easily into these cracks, and when it freezes it expands and pushes them farther apart and creates, in this case, these interesting things called hoodoos. So this is a freestanding rock column, and if we go over here and take a slightly different view, here's the same thing. You can see how it's freestanding and even has this kind of lid. And there's a number of these things, they're called hoodoos, throughout the sort of upper part of Crystal Canyon. All right, let's continue on our drive out to Point Sublime. It is aptly named. It is one of the, if not the most spectacular places in Grand Canyon National Park. The view is expansive in all directions and really quite spectacular. So here we are looking towards the south from the very end of Point Sublime, where we can see basically the entire suite of Paleozoic rocks. Down here in this canyon over here, the lowermost layer is the Tapete Sandstone. Above that here is the Bright Angel Shale. We have the Muav Limestone. Let's move over here. Now here's the Muav again. Above that is the Redwall. Here we have the Supai group. And it gets hard to see from here, but in there is the Coconino Sandstone, the Toro Weep, and the Kaibab up towards the top. You can see down this canyon, which feeds down into the main channel, and there's a tiny bit of the reflective part of the Colorado River we can see from here too. So the main last thing I want to point out to you is a monocline. So let's look off to our right, look towards the west, and zoom in on an area approximately there. Excuse me. There we go. This is what we see. Okay, so in front of us is the uppermost part of the Paleozoic sequence. So this is the Redwall limestone. Above it, all the way from here to here, this is all Sublime sandstones and shales. Above that is the Hermit Shale. Above that is the Coke, as some people call it, or the Coconino Sandstone, the Toro Weep, and then the Kaibab on the top. What I want to point your eye to is this suite of rocks here and here. This is the uppermost layer of the Supai group. It's called the Esplanade Sandstone. And here's the same thing over here. On this ridge, the rocks above it, the Hermit, the Coconino, the Toro Weep, and the Kaibab, have all been eroded away. Let me get rid of some of these red lines and point out the interesting feature here. Here, the Esplanade Sandstone is flatline. So here's the Esplanade, and it's flat. Here, the Esplanade Sandstone, notice it's kind of dipping. Here's the lower part. Here's the upper part off to our right. So off in the distance, the Esplanade Sandstone is folded, but in front of us, it's flatline. So what's the deal? So what we're looking at is a part of a geologic feature called the Crazy Jug Monocline. It's where rocks have been folded thanks to a faulting event in the past. There's a fault that runs through this area. We can't really see it from here, but it's called the Muav Fault. Same name as the Muav limestone, by the way. So the Muav Fault has caused the folding of the rocks here, what's left of them, as a part of, and the structural feature is called the Crazy Jug Monocline. So how this happens is this. Here we have a layer of rocks. There are many layers, but for simplicity, I'll draw just one. Okay, and we have a fault which forms, in this case, a reverse fault. So the rocks on the left side are moving up relative to those on the bottom. And so all of this stuff is being forced up. Now when this happened, there were many other layers on top of the Esplanade Sandstone. And so these rocks in here didn't fracture, didn't deform brittly, they deformed plastically, or they flowed. And so if we take this stuff below the Esplanade and push it upwards and to the right, this is the before picture. Let me draw the after. I'm exaggerating here. Here's that same fault. This stuff moved up. And here's our folded Esplanade Sandstone. So this flat-lying rock here is this part. And the rock that's been folded kind of down and off to our right, again, is this part. Now, remember, in my little diagram here, I'm exaggerating greatly. But nonetheless, that's the basic idea. We're looking at the axis of these folded rocks off in the distance over here, and the flat-lying ones are in front of us. It's a very common feature throughout the Grand Canyon, and we'll be seeing this again when we take a look at the South Rim field trip. All right, thanks for listening, and I will see you soon.